morning. Good morning, good morning. Whoa, that's louder than I expected. Yeah. Sorry, I'm also used to the walking around here, so being stationary is a little awkward for me. I also forgot to do my power pose earlier in the morning, so I'm gonna do that right now. Very, very happy to be here, and thank you for coming to the Washington, D.C. GDG DevFest today. And thanks to Cheetah and his team for organizing this amazing event and inviting me to be speaking here today. My name is Ray. I'm a developer advocate for the Google Cloud Platform. Now, how many people actually know or heard or used Google Cloud Platform before? All right, I'm in the right room. That's awesome. That's awesome. Cool. So I'm actually a developer advocate based in New York City, so I'm not very far away. There are like two things that I do. One is to bring some of the latest and greatest technology to developers like you. The second thing that I like to do is to actually stay in touch with developers and learn about your experiences and your feedback, so that I love to stay in touch and get in touch with you all. And I listed two ways here to get in touch with me. Really, it's just one of them is being used. So if you want to get in touch with me, just contact me on Twitter @Stalinism. Now, unfortunately, I'm one of those people who are not using my real name in my Twitter handle, and it's kind of hard to remember. It's actually a real word. How many people actually know what Stalinism means? Anybody? No? Wow. Oh, yes. Go ahead, Francesc. The what? The what? No. No. It actually means lead poisoning. Yeah. But that is not why I chose the name. That's absolutely not why I chose the name. When I chose the name, I didn't know anything about this word because it was more than 15 years ago. I don't know if anybody used IRC. On IRC, you have to pick a nickname, and I love the planet Saturn, so I use Saturn all the time until somebody else came along, and then we started fighting over the nicknames. And I don't know if you know how you fight over on IRC. You don't just talk about it. You pin the heck out of the other person so they get knocked offline, and then you can take over the nickname. Anyways, and so I got so sick and tired of it. Being Saturn 2 wasn't any fun. That's just stupid. So I decided to just use Stalinism instead. I didn't know what it meant at the time, and unfortunately, I'm stuck with it forever. So that's my Twitter handle. And as you can also see, I'm also one of the very few speakers who actually don't show my face in my profile picture. There are two reasons for that. Number one is because I like to take photos. I'm always taking the photos. I'm never in the photo itself. The other part of it is, sometimes I don't feel so well. Like today, I can just grab some random person and come onto the stage. You never know if that's really me or if. But today is the real deal. My name's Ray. You can check my ID later. All right. So I've been with Google for about 2 years, and prior to Google, I've been a developer, engineer, architect, and also project manager and such. I work in consulting companies and products company before for more than 10, almost 15 years. Aside from technology, I love to travel. That's my other passion. And I also love to take photos, as I mentioned. And here is actually a photo of me walking in a desert for about 4 hours in this southwestward direction for about 4 hours because somebody told me I can magically find a real oasis in the desert where I can actually stay overnight, and which I did. That was a lot of fun. But that's another story. If you'd like to know more, follow me on my Flickr.com account, where I have all my photos, or you can see what I eat every day on my Instagram, which is not Stalinism, it's actually Stalinism 2, which is kind of stupid. So anyways, I'm not here to talk about myself today. I'm here to tell you a story about Google. Now, what do you actually think about when you think about Google? I'm sorry? What? Logo. Yeah, I do have the old logo right now. I never had a chance to change the new one, but I'll show you something really cool in a second too, which is the even older logo. But as an employee, when I think about Google, I think about two things. I think about the free food in the cafeteria, yeah, and also I think about playing ping pong a lot because that's what I do in the office. In fact, I tell my manager, wait, this is recorded, right? Well, he knows this anyways. I tell my manager that my 100% time is my full-time job is playing ping pong, and my 20% time is developer advocacy, which is what I'm doing today. But no, in all seriousness, though, when you think about Google, you probably think about their search engine. This beautiful, simple, and elegant page. It only has a couple of elements. It's got the old logo on it, unfortunately. It's got the text box where you can search for whatever you want to search. And it only has 2 buttons behind the scenes, right? And then you just click on either one of them, and it's going to get you a result pretty close to what you wanted to search for anyways. And it's going to be able to do this by searching through billions of documents that's being indexed in fraction of a second. And this is actually not so different from 15 years ago. Not many people may have seen this before, but this is the like a beta homepage from Google from more than 15 years ago. And as you can see, it's even got an older logo. But the construction is very similar. You have the logo, you have the text box, and then you have 2 buttons to click on. Right. So the user interface hasn't really changed for the past 15 years. But what has changed is this graph. Now, I don't think that many people have seen this graph before, at least not many of you. But this is a graph that I took from another slide. But this is really interesting because it actually shows you the growth of Google search in the late 1998 and until the early 1999. And it's a little small, but I'm going to talk through this a little bit. So like in December of 1998, we had about 50,000 queries per day, only 50,000 queries per day. But within like a month, until January of 1999, it tripled to 150,000 queries per day. And then if you look even further, until April of 1999, just about less than half a year away from December, it's about 5 months, it grew 10 times to 500,000 queries per day. That's incredible growth in such a short time. And then you see all these jagged lines. It's not exactly smooth curve or anything like that. Well, those jagged lines, as I was told, they are actually availability issues because at the time the growth was so fast that the engineers actually had to make sure that we can meet the capacity and the resource needs to serve the growth and to serve the number of requests per day. And so there are some issues at the time. And obviously, Google didn't just run on a single computer. It ran on a couple of computers. So here are some interesting photos that, again, most people may not have seen before. Well, first of all, there were these server, desktop servers and stuff like that. I remember my startup, when I was working in a startup in 2000s, we only had one server. So obviously, Google was kind of ahead. So they had quite a few of these servers that's running the search engine. And then they moved on to these customized infrastructure and customized boxes where, these servers don't actually have cases on it, which people may know already. And then they move on to, these racks and these network cables and connected data centers. Until early 2000s, we have these massive amount of computing resources. In fact, this is a really nice photo as well. This is from one of the data centers in Iowa. So that's like one of the latest one, which is really, really nice and beautiful inside. I myself had a chance to go into a data center to visit before, and it's absolutely amazing. So from the previous graph, we can definitely see that the growth of search has really changed everything. And it has changed everything that Google has been doing in the past, from the software to the hardware. Because there's so much information that needed to be indexed. We will almost need like an infinite capacity to be able to search through petabytes of information in fractions of a second. And that also requires massive amount of computing power, and then we needed to be able to compute in parallel as well. So that changed how we think about software and how we design the hardware as well. In fact, we are running the software and these services. We're providing these reliable services on what is actually fundamentally unreliable hardware, because every hardware component is going to fail sometime in the future. And even if you're running on like a high-end computing resources or components, if we have like 100,000 of those servers, well, mathematically speaking, and based on probability, you're going to be looking at like one failure a day. Something is going to fail every single day. So fundamentally, all of the software that's been designed has been designed to be fault tolerant. And we use software to be able to deal with these faults automatically with as little human intervention as possible. But that's just one of the things that we learned so far. Now, most people here, if you're in IT, you're probably dealing with like a business unit of some sort. And then the business unit probably owns a set of computers. And then when you have a project, the project probably owns a subset of those computing resources. And then every computer probably has a name. And then when you're deploying your software to those computers, as I have done it before in my consulting days, we specify the names of the computers that we want to deploy to, okay? But at Google, we tend to think differently. Rather than just managing a cluster of computers, or a bunch of clusters of computers, or even racks and racks of computers, we are really managing an entire data center as a single computing unit in a way. And these are, this is like a photo from a data center campus. We have, multiple buildings in a data center campus like this, in which we can actually manage as one single unit. So how does a software engineer at Google deploy their application? This is pretty interesting. Because we have so much computing power, naming each computer to deploy to is almost impossible. So what we actually do is we will compile and we'll package the application, and then we'll write a deployment descriptor, what we call a job or a Borg job. And this job, and by the way, this is the best application that I have ever written. It's called Hello World. It serves thousands and thousands of users per day. No, I'm just kidding. But rather than defining and saying which computers that we need to deploy to, we basically just say that we need to deploy to a cell, or basically means a cluster of machines that's composed about maybe 10,000 machines in a cell, okay? So, and we don't really care about which computer is running on. So we just say, go and deploy into the cell or the cluster of machines, and here's the binary file that we need to deploy and run, and some kind of arguments. And here's another interesting thing. Rather than running these things in virtual machines, right, application in virtual machines, we're running these applications in containers. And with containers technology, we can actually specify the amount of memory that needs to be isolated for this application, amount of disk, and even the CPU share. Okay. Now, of course, if you're running a web serving application, you don't just want to run a single instance, because that's bad. So maybe you want to run 2 or 5, and all you have to do is to declare it in this configuration file, all right? And if you need to run like 10,000 of it, you just change the number to 10,000, and that's it. And behind the scenes, we have these cluster management system, or what we call an orchestration tool. It's called Borg. Okay. Again, I don't think many people have seen these slides before. So with Borg, what we can actually do is to deploy the application to the entire cluster, where Borg will manage, and determine how and when and where to deploy the application to. So this is how it works. We will store the binary file somewhere in like a shared file system or like a central repository. And then the configuration file that we just saw, we're going to deploy it to Borg with a Borg config tool. And Borg is going to see this file, Borg master is going to see this file, and then it's going to figure out, okay, I need to deploy this application with this amount of resources, and it's going to consult the scheduler to figure out, which one of these 10,000 machines or so actually has the capacity to run the application. And every machine has an agent on it. It's called the Borglet. And basically, the master will say, hey, Borglet, do you have enough capacity to run this application on this machine? And if it does, then it's going to go ahead and fetch the binary file and just run it locally on the machine itself. And we do this for all of the 10,000 replicas that we need to deploy. Okay. And the deployment speed is actually quite amazing. To launch 10,000 tasks, like what I just described, probably takes about just a little bit over 2.5 minutes within our data center in our clusters. Okay. And so once you do that, all of a sudden, like, again, without knowing which machines we're deploying to, we're deploying to this entire cluster of machines, and Borg is going to be able to manage the deployment task for us. Our data center is also very, very efficient in terms of power. We are the first to build a chillerless data center. Also the first to build a seawater-cooled data center, which is pretty cool. That actually makes our data center super effective and efficient. I don't know if anybody understands like power usage effectiveness and the PUE numbers. No. So like a PUE number is basically determines like it's a measurement of how effective the power is being used for computing. So for example, if I understand this correctly, a PUE of 2 means that every watt of power that's being used for computing, there's another watt that's being used to do the other things like cooling. right? So a PUE of 2 means 1 watt of power for computing and another watt being, essentially wasted and not performing computing. And if I recall correctly, the industry average last time I checked was about 1.7. And so like within the Google data center, this is like an average graph that you can actually find online. We had PUE that grew from 1.2 and all the way down to about 1.12, which is extremely efficient in the industry. And to support all these computers within the data center to not just talk to the internet and both in ingress and egress traffic, they also have to talk to each other as well, okay? And it wasn't very long before they kind of figured out that the off-the-shelf components in networking was not enough. So the engineers actually set out to build these customized networking infrastructure as well. And there's a really good blog on this that's published a couple weeks ago, and you can actually find this online. But they have iterated through a couple of different networking setups, and now we are using what we call the Google Jupyter Superblock. And that is pretty cool because this networking infrastructure allows us to transfer up to 1 petabits per second in bisectional bandwidth, which is super awesome. Now, to put that into perspective, the entire public internet, if I recall correctly, is getting close to about 200 terabits per second. So, inside the data center with the technology that we have, we're already way beyond that. So the innovation happened throughout the years, all the way from 15 years ago to now. But I'm going to focus on a couple of things that's relevant to software. Here's an evolution of different types of technology that's being either publicized in research papers from Google or things that we know of publicly already. So in 2003, there was this system called GFS, which is like a Google file system. It's a resilient and distributed file system that was initially designed to basically hold web indexes. And you can literally store as much data as you want, and if you exceeded the capacity, then we can just kind of add more drive and add more capacity to it. But with so much data, we actually need a way to process it in parallel so that we can get the result faster than just being able to process in a single thread. So for that, we published a paper on MapReduce. Now, MapReduce, now people think about it as almost the de facto way to process big data, right? So that was actually pioneered in 2004 by Google as well. And then we needed a way to store semi-structured data. So GFS is good for unstructured data. For semi-structured data, we invented Bigtable, which was also published in a research paper in 2006. And now we have open source software that do very similar things as well. And then, rather than being able to MapReduce job every single time to query the data, because that's kind of time-consuming, then what we invented in 2008 is called Dremel. Now, Dremel is really cool. I actually had a chance to use Dremel on a daily basis more than a year ago at Google. It is a system where we can actually query with SQL-like syntax. We can actually query hundreds of terabytes of data in seconds, okay? And we can actually do this without having to build custom indices. Now, if you think about how regular SQL-oriented server works, for you to even query hundreds of gigabytes of data, you definitely need indexes, and then you also have to be able to optimize your queries and stuff like that. But with Dremel, we're able to query many of the data sets without even needing to build these custom indexes at all. And then we have Spanner and Megastore and Colossus. I'm not going to get into all of these, but like Colossus is like the newer version of GFS. And then we have other ways to process data since MapReduce, because MapReduce is from 2004. And now we have something new, which is called Flume in 2010. And Flume is a way for you to write these pipelines, data processing pipelines, in a way that developer understands. Rather than decomposing them into MapReduce job, you can literally write a processing pipeline, and then behind the scenes, software is going to decompose the pipeline, turn it into a graph, and then optimize the graph, and then turn that into very efficient MapReduce job behind the scenes. So no longer do you have to deal with the lower level MapReduce optimizations. You can write these high level language, high level processing pipelines, and then we can turn that into MapReduce behind the scenes. And then from the computing side, in 2009-ish, we also pioneered containers. Like I said, we basically run everything in containers, and we manage it through Borg. And containers, like in 2009, we published C groups to Linux kernel as part of the open source projects. So that's actually the building blocks for many of the container technology that's being built on top of today. So many of these innovations, many of these research papers that's being published, they actually drove innovation in the open source community as well. And I do believe in open source. I'm a heavy believer in open source. I used to work at a company called Red Hat, which is a 100% open source company. And I think that open source definitely helps drive innovation. And these ecosystems are really amazing at what they do. So for example, Google MapReduce, that kind of inspired Hadoop, which everybody kind of associate with big data today. And Bigtable kind of drove inspiration for Apache HBase. Borg, which I mentioned earlier, how we actually deploy to all of our machines. Now that actually is taken, and we actually took those experiences and we created another project, open source project called Kubernetes. And same thing, the container technology is, so it's being used by Docker, and Dremel is kind of inspired by with Apache Drill. So when I think about Google, just aside from the food and stuff, when I think about Google, I think of Google as fundamentally almost a infrastructure company, right? Because we have these massive infrastructure behind the scenes with a really, really nice user interface, which is search. And we took that and we are able to bring up all of these other services and applications like Gmail and Drive and Map. And all of these are being built on top of the same Google infrastructure that I just kind of described to you. And these applications obviously change people's life on a daily basis. So what does that mean for us, for developers that's here today? Well, in 2000s, I actually worked in a startup, like I may have mentioned before. And in that startup in 2000, we actually ran everything on a single server. I don't know if people do that today anymore, but when I do mean everything, I do mean everything. Like the web server, the email server, the application server, the FTP server, the game server, everything is on that one box. And we also put that box in a closet somewhere. Of course, nothing could go wrong. Right? Nobody dare go inside the closet, and nobody ever trip over the wire, so that's fine. But why did we do that? It's not because we wanted to. We definitely would love to have more computing power, but it's simply because that we couldn't get more. It was hard to, these boxes could be expensive. It was hard to, create your own data center to provide more capacity, for example. And that really constrained us in terms of the type of application that we could build. Okay, think about it. We actually have thought about, hey, it would be nice if we can do X, Y, and Z. But we couldn't because we don't have enough computing resource to do that. So it really limited our imagination in terms of the applications that we could write. But today, all of those technology, many of those technologies in the entire Google data center, in the past, it's only usable by the Google software engineers internally. But today, you can actually use many of these services in the Google Cloud platform as well. And that's really, really amazing to think about. All of the things, all of those technology, all of those innovations that I just described, even those networking components behind the scenes, those amazing data centers and those efficiencies, you can actually take advantage of that simply by using the Google Cloud Platform and deploying your application within it. Then you can actually take advantage of many, many of these services that we actually expose as a service that you can use. So what are these some of these services? I'm going to go through some of them pretty quickly. When people think about cloud today, I think when most people think about cloud today, they can think about virtual machines. Okay, they think about virtual machines that you can bring up very, very quickly. Now, of course, in Google Cloud Platform, you can definitely run these virtual machines as well, and it is called Compute Engine. So with Compute Engine, you can bring up virtual machines very quickly in a matter of 30 seconds or less. and you can spin up as many instances as you want, and then you can run whatever operating system that you want and install any type of workload that you want. But just by using Compute Engine is basically just scratching the surface of what cloud is possible for you. Because when you think about it really carefully, when you're just using virtual machines, you're just managing another machine anyways. It's whether you're managing the machine that's physically on premise, or if you're managing a machine that's in the cloud. In the end, it's just the same number of machines that you have to manage. But we are thinking beyond that. What we are doing is to provide services and these tools so that you actually don't have to deal with machines at all. And a good example of that is the Google App Engine. With Google App Engine, it's a platform as a service where all you have to do is to write code, and then you can deploy it. And behind the scenes, Google will be able to manage all of these virtual machines for you behind the scenes, all of the computing resources for you behind the scenes. And that's really hard to think about because you no longer really need to think about how many machines you need, or what operating system I need to install, or dealing with those security patches for those operating systems. You don't have to think about those anymore. With the App Engine, for example, you will be able to just write the code and deploy, and over and time again, I hear stories like one of these, where a small startup, they don't have many engineers, and they're just making something amazing, and they are using App Engine, and they grew really, really fast. Okay, I hear this kind of stories all the time. I have many type of these slides, and this is just one of them. So this company called StonePop, they are a small startup in 2012, and they were able to acquire 100,000 daily active users in just a month. Or 2 months since the launch. And they were able to acquire 500,000 daily active users a couple months later. And within less than a year, they acquired 16 million users in less than a year. Now, how would actually a startup grow so fast and be able to support the capacity like that? In my startup, in 2000 with just one server, that would be nearly impossible. But in this case, because they're using App Engine, they were able to basically dedicate all of their engineering time to writing what they do best, and to write their application, to write their games, and let Google Cloud to handle infrastructure for them. Okay. So for them to achieve that many users, only took about 6 engineers, which is really, really amazing if you think about it, because all of them are able to dedicate their time to build the application and not necessarily dealing with the back-end infrastructure. And we also took that idea to being able to process and deal with big data, okay? So if you're dealing with, I don't know how many people are dealing with big data today. Anyone? Some? Yeah, quite a few. But if you're dealing with big data, you probably, sometime in your life, you probably installed like an entire Hadoop cluster of some sort. And you have to kind of provision the machine for that. You need to provide the disk and such. And then you have to manage those clusters, and then you have to deploy these MapReduce jobs, and you have to manage the operating system and everything like that. So basically, we took the same idea of not having you to worry about those things. We'll apply it to big data as well. So we have a couple of services that's really, really nice and easy to use. So for example, for BigQuery is really the public version of Dremel, which I described earlier. So if you want to be able to query terabytes and terabytes of data in seconds, you can do that too today as well by using BigQuery. It's not something that we can do only within Google. You can actually use the service today as well. And you can actually query up to like a terabytes of data for free if you just try it out and play with it. We also expose Bigtable in a public service as well. And that's actually available as a beta today. And we provide the HBase connectivity, so you can use it with the same HBase protocol. And remember Flume, where we don't really need to write MapReduce anymore? The processing data pipeline that we write that gets converted to MapReduce automatically? Well, that's also exposed as a service today, and it is called Dataflow. And with Dataflow, you can write your processing pipeline with Java SDK, and you can describe how you want to process the data, and then you can then deploy it to Google Cloud Platform. And behind the scenes, we will then spin up the infrastructure that's necessary to process your data for you, okay? Again, in all of these services, there is no infrastructure for you to manage or to worry about. And if you think that's cool, then you should definitely try out Firebase as well. Firebase is probably one of the coolest technology I've seen in the past 5 to 10 years. It is a real-time backend as a service. I'm not gonna go into detail on this too much today because I think there's another session, but definitely check them out. You're literally able to write a real-time, a very rich application simply from just writing the client-side code without even needing to run anything on the server, okay? Well, the server is actually hosted by Firebase, but you don't have to worry about installing your own database or instantiating a new database or anything like that. You just register an account, you create a project, and then you can just connect to it and just use it. It's really amazing. I highly encourage everybody to try this out or to check out the session and the collab later. So Google Cloud has, we have quite a few sessions here today. We have a Kubernetes workshop. So Kubernetes is really the public version of, it's heavily influenced by Borg. So Kubernetes is this public version of the container orchestration tool where you can actually use to deploy and manage your clusters. We have Frances Campoy that's here today. He's going to be leading like a Go and App Engine session later. Really, really awesome. And we also have like quite a few workshops as well. There's also a cloud overview, a technical overview by my colleague, Brett McGowan. And then there's also a Firebase session, a Go Code Lab, and a bunch of things tomorrow as well. So if you'd like to try out any of these things, or if you have any questions, feel free to come up and ask questions, or just come to one of these sessions and find one of us to talk to. So today I'd like to end with this one note. I think it's a very exciting time to be a developer today, okay? Because not only are we able to search all this information at our fingertips, for developers, if you have an idea, if you have something that you want to build, and if you have the skill set, you have all these amazing computing power that's provided by Google Cloud that you can actually use at your fingertip as well. Right? No longer are you restricted by what you can or cannot build, right? Because of computing resource or because of technology. Many of the companies and some of the predecessors, they left us with all these amazing services that was built on top of many of the experiences from the past, and now they are exposed as these services you can just reuse. So it's really exciting time to be developers and to be able to take advantage of all of these technology and all of these power. So I challenge everyone here today and tomorrow and also in the future, to really think about what you can actually do with this type of technology. So that's it, and thank you very much for your time.